It's about 3 weeks after our last video, the three-way ANOVA with no repeated measures. Now we're seriously running out of supplies, fresh water. The bad news is we're losing about one person a day, so we're down to about 20 survivors. This is the problem. Mr. Zombie. He's going to turn your loving family into this. That's the problem. Whenever somebody dies, they join the other side. So from the three-way ANOVA, we did the weapons. Right, there's the loud ones. There's the quiet ones. And here's the handheld. And from that analysis, we discovered that your best chance of returning from a mission is to go by yourself with a handheld weapon, right? I'm assuming that the guns attract noise and the bows and arrows and the crossbows and the boomerang. Don't know. Could be a vision thing, but we're not sure. But the best way to go out is to go out by yourself with a handheld weapon. So that was the last video. So for this analysis, we're trying to answer this question. The foragers are bringing back less and less supplies every day. We're getting reports that the Costco's and the Walmarts and the grocery stores have been taken over by like the army and the military, people with guns. They're very, very well fortified, so they're surviving on the stuff that's there. And that's leaving people like us to go scrounging for more food in different places. We have to send more people out every day. It's going to cause us to have to leave this place. We're going to have to find some other place where we could have a better chance of survival. So today's question is the number of pounds of forage consumables affected by the number of missions. So the more a person goes out, is that affecting how many pounds they bring back every mission? And the second part is there a difference between the male foragers and the female foragers? So does gender matter? So those are our two questions we're going to answer with this test. Now, everybody in this analysis have foraged at least 5 times. Okay, so they're all experienced foragers. And our DV is going to be the number of pounds forage consumables. So a consumable is, water, food, smokes, cheese whiz, that kind of stuff. So our first IV is gender, right? We want to figure out if there's a difference between the males and the females. And our second IV, this is the strange one, is the missions, right? They're going on 5 missions, right? The first mission, we count how many pounds of food they bring back. The second one, how many pounds, third, etc., etc. So we're recording how many pounds of consumables they bring back every time, and that's 1 IV, and that's the repeated measure, right? Everybody in the study will have a first and a second, a third and a fourth and a fifth, etc., etc. So that's that's the repeated measure. It has 5 levels. It's 1 IV. So that makes our test a 2x5 mixed ANOVA. Right? The 2 stands for the 2 levels of gender. The 5 stands for the 5 repeated measures. With repeated measures. That makes this a whole different test. So, IV, we're going to break it down into 2 levels. Right? A1 are going to be the males. A2 the females. This is your between group variable. Right? Is there a difference between the males and the females? Between group. Your second IV is your repeated measures, right? Also called your within group. If everybody gets the same exact treatment therapy, if they all go on to missions, right? That's everybody gets the same process. That's called a within group. It's got 5 different levels, right? First mission, second mission, third, fourth, fifth. So here's a table of data. So this is the male group. This is the female group, right? So on the first mission, this guy brought back 5.3, 6, 4.1. These are all pounds of consumables. Same with the females. This is what they brought back. Okay, so this is mission 1, mission 2, mission 3, mission 4, mission 5. males, females. So what I'm going to do is I'm going to give each row a subject, right? So this is the first person. This is the first guy. Brought back 5.3, 4.7, 4.6, 3.9, 1.5. You'll notice that it seems to be going down for the males, but not necessarily true for the females. Okay, so that's going to probably answer our interaction question between gender and the trials or the missions out there. So let's go ahead and we're going to have to find the row totals and column totals. We're going to use those in our calculations, like always. Kind of self-explanatory, right? This is the sum of these. This is the sum of these, etc., etc. These row totals are the individual subjects' totals, okay? And we get a grand sum for the males and for the females. Very important. We're going to use these in most of our calculations. So we have the data. Let's look at the two-way mixed ANOVA source table. It's going to be different. This is how it's read, right? A by parentheses BS. Whatever's inside the parentheses with the S is the repeated measure. So here's a two-way mixed ANOVA source table. Also can be written like this, right? Two-way mixed ANOVA. And you got your bracket terms, your degrees of freedom, mean squares, and your F scores. So let's calculate bracket A. Right? This sigma means the sum of all your A groups, and that's the little j means groups of A, and then you're going to square them. But something important with the repeated measures, N can be substituted with S. S is the number of subjects. So let's go back to our original table with all our data. A lot of people like to what we call collapse the data. Let me show you what that means. So we take this table and we turn it into this table. So what you're looking at is you're looking at the A1 totals, the A2 totals going this way. Going down this way, right? The columns, you're going to get the B1 totals, B2 totals, etc., etc. So you can get everything you need from this original table. But from our own personal experiences, if you do collapse them, it just makes it easier to look at, easier to calculate with. So let's figure out what the row totals are for A and A1 and A2, and the column totals for B1 through B5, and the grand sum here. Okay, that's everybody. So if you add these going this way, it should equal 205.3. If you add down, it should be about 205.3. And these are rounding. I rounded a lot, so forgive me. They're not going to be exact. We're in a hurry here. Okay, so bracket A equals the total sum, that's what the sigma means again, each A group squared divided by the number of levels in B times the number of subjects. Okay, so it's going to be 89, 115. You're going to square them both, add them together, divide by 25. So there's your A bracket value. We're going to repeat the same thing with B. That little K means the groups of B. So there's just everybody that's in the B groups, which are columns on our thing, okay? So here's our B column sums, right? 45.7, these going this way. So we're going to take all of those. We're going to square them, add them up, divide by the product of the number of levels in A times the number of subjects in each group, right? So that's 2 times 5. So we get a bracket term of that for B. Now we have to look for the interaction between A and B. So we have to take everybody from all the groups and then square them and divide by just S. A good reminder is, a good trick is, the denominator to find the bracket term will never have any value that's inside the bracket. Okay, so we have A, IVA, IVB, and S is the number of subjects in one group. So you'll notice there's AB here, so there'll be no ABs as a denominator. That's a good reminding trick in case you get them all backwards. So what this basically means is we're going to take all of these scores, right? These are your A1, B1, A1, B2, and all of these scores, and we're going to square them all. Right? 22.5, 20.0, ... all the way down to these 24.0, right? We take each and every one, we square them, we divide it by S. And that gives us our AB bracket term. Moving right along. Now we need the AS bracket term. This one is new, right? This is with the repeated measures only. So you're going to take everything that's in the AS group, you're going to square it, and that little I means individual, but let me show you with a graphic. You have to take just simply the S1s or the S scores here, right? These are the total S scores. That's what the S means. So we're going to look at these two numbers here again. I'm going to collapse it down a little bit. See, this is kind of awkward. So I'm going to reformat this. So it looks like this, right? S1, S2 for the males, S1, S2 for the females. I simply rewrote them in a much easier to read collapsed form. I'm going to go ahead and fill in the column totals. You might not need those all the time, but I just do it by habit. So there's the column totals, and there's the grand sum again. So to calculate bracket AS, we're going to take each and every one of these guys, right? A1 at S1, A1 at S2, A2 at S1, A2 at S2, all of these guys, right? That's what this means. The sum of everybody in this giant group here. We're going to square them all, right? 20 squared, 23.8 squared, all the way down to 14.6 squared, 23.9 squared. And we're going to divide by the number of levels in B. So now we have our bracket AS term. T stands for total. What that means is we're going to take the grand sum, we're going to square it, and we're going to divide by little a, little b, little s. So number of levels in A, number of levels in B, and the number of subjects in one group. And we get a grand total of, bam, got our bracket T. Last one is your bracket Y. That's your within group variance. This is the heavy lifting. You have to go and take every one of these entries, 5.3 squared, 6.0 squared, 4.1 squared, all of them. And there's a lot, right? There's 50 of them. So you got to take them all. You got to square them all. And divide by 1. Because with the within group, it treats it all like one giant group. So, but now we have our bracket Y term. So we have all our bracket terms. And then the rest is just plug and chug. So hold on to your lug nuts. So here's the two-way mixed ANOVA source table. Dun, 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 dun. So there's a warning here. Warning. With repeated measures, with mixed ANOVAs, you have two different error terms. You have one error term is strictly for the between group. Okay? That's this guy, right? Error term between groups. Your other error term is for within groups. Okay, use a different error term for your repeated measures. That's this one. That's the B cross S sub A. Okay, so there's two different error terms. What I'm going to do is I'm going to switch the order of the source variance just to make it easy on myself. Right, I'm going to move this one, the error term for the between groups, right under the between groups here. Okay, and so for anything with B in it, I put that error term underneath there, just to keep it clear for myself. You don't have to do that, but All right, so we're going to plug and chug these values into the source table. So here's source A. Bam, bam, bam. I did all the math already. Here comes the S sub A, right? Here's the error term for A. So to find this F, I'm going to divide 13.42 by 4.8, but I'm going to do them all at the end of the video here. So here's B, after all those calculations. Here's AB, right? I'm going to use the bracket terms, get those numbers. Here comes the error term for the repeated measures part. Bam, bam, bam. So anything with B in it, that's going to be my denominator, right? Anything with no B in it, this is going to be my denominator. So here I go. I'm going to calculate the F scores for the between groups first, right? This mean square divided by this error term, and relatively small f, okay? Now I'm going to do the repeated measures. So this term, this f score is going to be 2.05 divided by this error term. And I get that. And then for the interaction, it's going to be that divided by that error term, and I get that. Those are pretty large f's. So it looks like there's going to be a significant difference between the different missions and the interaction somehow between gender and the number of missions. Okay. So I looked them up in the book. This is not significant. For degrees of freedom of 1, 8, it should have been over 5 to have significance. So the source A overall, in other words, there's no significant difference between the genders by themselves, right? There's no main effect A, but there is a main effect B. So in other words, there is a significant difference between mission 1, mission 2, mission 3, mission 4, mission 5. And I think we saw that with the males. And there is an interaction with the number of missions and gender. So I think, yes, there's a difference between the males and the females. That's what this is saying. So our basic interpretation is there is no significant difference overall in gender, right? There's the males, there's the females. There is some difference, okay? There's always some difference, but according to our calculations, the difference is not big enough to be considered significant. But there is something going on with the number of missions, especially with the males, right? Here's the first mission. Second mission, the males are tending to go down. The females, going down a little bit. Third mission, again, males seem to be going down a little bit, but not the females, etc., etc. So that's what the significant difference in the missions means. That's the B. And in the overall interaction between gender and the missions, there is a big difference. I'm going right to the B5 column. Look how small these numbers are compared to the females. Their numbers are pretty much close to the first ones. Not perfect again, but yeah, there's your interaction between the gender missions. And I think that's a good place to end up part 1. We're going to go ahead and do this in SPSS. I'm going to have to show you other things that you need to look at. So that's it. MGZ, fighting the zombie man.